All right. So also like if you guys want, y'all could bring in y'all laptops and knock out the homework here too. In case nobody wants to do their homework at home. I get it. You know. Last time I actually had this class, like nobody took their homework home. Everybody used to just finish it in class. You know. Look at it. It's light. You do it in the middle lesson. It's being recorded, so it's not like you're not gonna see it. Yeah. Yeah. But let me answer a couple questions real quick. Hold on, before I even start this up. Get just open up Google over here. All right, so let's say you're on Google, right? And you want to get to Brightspace, for example, right? You could just go to the regular BCC website, right? Everybody know how to get there, right? And then eventually it'll load, all right? I like when I see people on the website that I know. I'm like, I know that person. All right, so you go to where it says quick links right here, right? These are all the links that you need right here. Here goes Brightspace, here goes CUNY First, this your email right here. So this is how I get to whatever I need to get to, you know? So that's one thing. I'm sorry? Yeah, you could bookmark it too and all that as well. Yep. Um, let's say that you want to go to web work, right? So here's the long way of how to get to web work, right? Without using Brightspace. So you go to BCC, or we type in, excuse me, BCC and web work, right? And you just click on the first link, right? Yeah, BCC and then web. Well, it doesn't matter, right? When you get to this link though, right? I recommend you use the find function. So if you're using PC, that's Control F. If you're using a Mac, that's Command F, right? Yeah. So boom, right? After you get there, because this is a lot to scroll through, as you can see, right? So first thing you do, type in the year. So 2025, right? And it's gonna highlight all of the 2025 links, right? And then type in the semester that you're in, right? So we're in the fall semester, right? Now it's gonna highlight all the fall semesters in 2025, right? Then just put the first letter of my last name, L, and there it is, the first one. Yeah, and that's it. And then now you just type in your username, your password, and boom. All right. Questions on this? Go ahead. Mm-hmm. 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 On the phone, you might gotta do the yeah, you might gotta do the, you know, but you're gonna go down to where 2025 is fall and then Lee and Matt 23, D16. That's the whole thing. D16. Yeah. So first look for the year, 2025, then the semester, which is fall, and then the last thing, Lee. Hey, how are you? I know you got mad free goodies coming in. Did y'all see the park across the street? The park was going crazy. Yeah. It's Thursday. Yo, they had a whole bounce about. I was about to go in there, but I was like, I got class. I can't. hmm Yeah, yeah, yeah. So I'm just showing everybody how to get to web work in case they have like an issue. Yeah. Were you able to log in though? Try. Uh-huh. Paul, and then Lee, L-E. And then make sure it's Matt 23, B16. Yeah. This is the long way to get to it if you don't have access to Brightspace, right? But you should get access to Brightspace. There's an app that you can download called Brightspace Pulse, Pulse. If you get that, you can have the full access of Brightspace on your phone, you know? Yeah. First name and then last name. Let me see. Yeah. Doesn't have what? Oh, the Wi-Fi? Oh, I got you. So look, let me see. So you want to click on where it says BCC, right? Right. And then connect. Yeah. And then perfect. So what's happening is that they're asking you to update your password. Every you did that? Okay. I mean, you could change it right now because it's prompting you to do it, you know?
Right here?
Yeah. But
Okay.
make sure you remember it, because when you change it here, that's changing your email password and all that, you know? Let me see. No, no, it shouldn't matter. The modality shouldn't matter. Let me see. So that's the username and the password. Yeah.
Tyler, it's what you said, it's first and last name.
Mm-hmm.
You should have. It says invalid. I don't know if it's gonna start.
But you put that as a password too? That's weird. That's weird. Let me see. Let me see.
Crap. Definitely.
Say your first name is Tyler. Um, what else could I show you? Let's see. What that is. Okay. Let me switch my screens one last time. This is probably the last time I'm gonna show y'all this, so check it out. All right. So this is Microsoft Copilot. All of you have this for free. All right. No, it's not ChatGPT, but it's something. So you can put in whatever question you have here and just ask it, show me step by step how to do this. Right. So like let's say I have 12 plus, I don't know, -15, right? Show me step by step how to do this. Google will never do that. It'll just give you the answer. This is excuse me. This is Microsoft Copilot. Yeah, yeah. Got you. Yeah. So you see right here, gives you step one, understand the numbers. 12 is positive, -15 is negative. Adding a positive and a negative number, right? It breaks it all down to you. Apply the correct sign, boom. Can't beat that, right? You want to go a step further, you could even ask it to read it to you. You ain't even got to read it yourself. How about that? You know? I do that actually. I would like read it to me, like words be too much. But yeah, you can do this with everything in this class. Like put in the question, Like show me step by step how to do this, right? Then after you understand it, you know what? Give me another question like this. All right, bet. Now I got to figure that out. What's 8 plus negative 11, right? Like, yo, for sure. I know the answer is positive 19, right? Why is it saying correct? Jesus. That's why I hate AI. All right, there we go. 3. All right. And then negative 3. Okay. Whew. All right. Because I put in a wrong answer and it looked like it was saying like, yeah, you're right. And I'm like, what do you mean? I did that on purpose, but yeah, you can ask it for other questions just like the one you just did, just to make sure you further understand, right? You can put all your information on into it, right? The class information I'm talking about. And then you could say like, all right, make me a test. Right. Say it's like it's about to be test time, right? Make me a test. And they'll actually make a whole test for you that you could do. And then you'll be like, show me the answers. All right, show me the answers. Yeah, how you do this question step by step. It does that. You know? Yeah. Mhm. Another question like this. Yeah, exactly. Yeah. You can make an entire worksheet from your homework. Absolutely. Mhm. That's pretty cool. Yeah, that's good. I like that method. Yeah, I like that method. So yeah, take advantage of your resources. This is 100% free. Not gonna cost you a dime. All right. I could do it. All right. That's fine. That's fine. I actually use this all the time. I ain't even gonna hold. I'll be honest with y'all. How y'all think y'all get y'all test? Give me a question just like this. Copy paste, like you know. So if y'all happen to use it and accidentally get a test question, it's an app too. Yeah, yeah, yeah. So you know how you log into your BCC email, right? That's how you access this. Yeah, yeah, the same thing. Yeah. Mhm. Yeah, Pulse is fire. Not just for this class, for all your classes. Because anytime there's an announcement that they give out, you get it. Huh? CUNY BCC, not BCC. CUNY BCC. Yeah. No, no, no. First name and then last name. No, no number, no dot. All lowercase. Yeah, and that's the same thing for the password. Yeah, same exact thing. All lowercase. Maybe copy and paste it. No, no, that's not it. Like copy and paste the username.
Oh, this one?
Yeah. No, this copy and paste the username.
Okay.
So control C and then control V. Okay, you can do it that way.
And then just pick it up from?
No, 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 just paste it in the password. It's the same username and password.
My.
Yeah.
Okay.
And that's everything. So you just click through them. It's real easy. You could probably knock out all of it tonight, like right now. Huh? Yeah. We're finishing the lesson for that.
Okay.
Yeah. So I posted today's homework too in the bunch. So if you see some questions there that's like, y'all don't even know how to do that yet. We ain't go over it yet. So that's why. Yeah. We about to do it right now though. All right. So any questions or I could start? Good? All right. So let's do a little recap, right? Let's say I have 15.3 divided by, you gotta a negative 0.03. How I do this? Hmm?
Do you change the second sign and then turn that into multiplication?
Mm,
That again?
I could do that, right? So if I was gonna do that, I'd have to change a decimal into a fraction, and then I can go about and do that. But how I would like for you guys to do this actually is actually use long division to do this. All right. So the second term, right, would be like your denominator, right? So let's say if I rewrote this, this would be 15.3 over the negative 0.03, right? So you remember your denominator goes on the outside. So negative 0.03 divided by the numerator, which is your 15.3. Any questions on that? We good? All right. Yes. Yes. All right. So first thing, a positive divided by a negative is a negative. All right. Good. All right. And then we're going to move our decimal places over, right? Because we don't divide decimals, right? We divide whole numbers, right? So you have to be fair. What you do to one, you have to do to the other. Basically, you want to get it, both of them, you want to make them whole numbers, right? So how I would do this, I'm going to start off with the 0.03. I'm choosing that one to start with because that one has the most digits after the decimal place. So you want to focus on the one that has the most digits after the decimal place. Move that over however many times it takes to make it into a whole number. In this case, it was 2, right? So what you do to one, you got to do to the other, right? So boom, 1, 2. Just like that. Then we're going to add a 0 there. So negative 0.03 is the same as negative 3 divided by, oh, no, excuse me, 1,530, excuse me, divided by negative 3. Just like that. All right. So now it's simple. Let's go straight through. We know our answer is going to be negative, so let's just put it out right up here. All right. So, 3 goes into 15 how many times? 2 times, right? 3. How much? 5, right? All right. So now negative 5 times negative 3 is what? Positive 15. All right. Then after that, we're going to subtract, right? So 15 minus 15 is just 0. Bring down the next number. Let's use 3. Now, negative 3 goes into positive 3 how many times? Once, right? Well, technically negative 1, but I'm just going to put 1 here, right? And 1 times negative 3, that's just the negative 3 right here. We're going to subtract that. Excuse me. That's 0. Bring down 0. Negative 3 goes into 0 0 times. 0 times negative 3 is 0. Subtract 0. Boom. Right? You got the answer? That's what I'm talking about. That's what I'm talking about. And that's it. Yeah, we got more. I mean, y'all got it all in your homework, though. Y'all got some good examples in your homework. But we straight on this? Long division, boom, 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 give you the answer, call it. All right. Good to go. So you want to figure it out?
You don't wanna put the decimal back to that negative 510, it just stays there and that's it. We don't.
Yeah, because
No,
the only time I'm putting a decimal is like, let's say that I had to add an imaginary 0. Then the decimal would come here and the decimal will go up here. But in this case, everything terminated at 0, so I don't need it. You know? One sec. Mm-hmm.
So there's like one particular, we don't have to, we don't have time, I understand. Just, this is confusing the living crap out of me, like I just.
Make them equal. All the fractions. They have different denominators, but you can make them equal. Mhm.
One. That's the one with A, B thing.
Just one.
So if I have like 3/4, right? And I'm telling you that that's equal to like x over 40, for example, right? What would x be?
You want me to make like a common denominator with this,
You could.
right?
You're close. The x wouldn't be 10, it would be no, say it again? 30. Because 30/40 is the same thing as 3/4. Yeah. That's it. That question just has multiple of those, you know? It just is. They're equivalent. Yeah. They're equivalent.
So you pick one number, you gotta multiply both of them by.
To get the other one, yeah. But in your homework though, it's like they're giving you a part of a fraction already. So then you just have to figure out what the top portion is, and then that's it. You know? Yeah,
Try this again.
I got you. Yeah. And they're all equal, so it's just well. Doo, doo, doo. Let's see if this works. Fingers crossed. Damn it. Okay. Gotta really investigate that when I get a chance.
But that, couldn't you do just like multiply them and then you'll use the sort? That's what I was getting.
Yes. Yes, you can do that.
That's how I did it.
Mhm. You can do that. Cross multiply and solve for x. Mhm. Yeah. Mhm. All right. So let's finish this up real quick. So we're doing operations with sign numbers, right? So exponents and square roots, right? Whole number exponents indicate repeated multiplication in the same way that whole number multiplication represents repeated addition. The base of an exponent expression is the quantity immediately to the left of the exponent, right? So for example, the base of -4 to the 10 power is -4, right? The parentheses immediately to the left of the exponent tells you what the number is inside. Also, the base of -2 to the 5th power is 2. Unlike the previous example, the quantity immediately to the left of the exponent is 2. So this is something like really important that we want to see, right? Those parentheses matter, right? So if I have, for example, -2 to the 2nd power, right? What does that mean? That means -1 times 2 times 2. But if I have -2 in parentheses squared, that means -2 times -2, right? Just so that we're clear about that. Anyway, so since we will only be concerned for now with whole number exponents, the rules for exponentials with negative bases follow immediately from the rules for multiplying sign numbers. In particular, you should notice the following. So the sign of exponentials with a negative base, so a negative base raised to an even exponent is positive, and a negative base raised to an odd exponent is negative, right? So here's what that means, right? If I'm going to pick on 2 again. If I have 2, let's say -2, raised to the 3rd power, right? That answer is what? So that gives me -8, right? Right. But say I had -2, Right there. The answer's right there. Say I had -2 raised to the second power, right? That answer is +4. So basically, when you raise a negative base to an even power, the answer is going to be positive. If you raise a negative base to an odd power, the answer will be negative. That's all that's saying. Mhm. Right.
So that was
If the
five.
base is negative.
Five
Yeah.
would be negative.
Right. Yeah. Mhm. And of course, we will have square roots as well. We love square roots. All right. So we will also from time encounter square roots written with the square root symbol. Remember that the square root of a number is the non-negative number, which when raised to the second power squared gives the original number. So for example, the square root of 16, we know is 4 because 4 squared is equal to 16. So for now, we won't go into the different issues that arise from the operation of taking square roots. In fact, for now, we will only consider square roots of perfect squares. So whole numbers, which are the second power of another whole number, the first few perfect squares are 1, 4, 9, 16, 25, etc. Right? So we're talking about perfect squares, right? So that's a number multiplied by itself, right? So if you haven't worked with perfect squares for a while, you should take a moment to make a list from the first 12 or the first 15, right? I work with the first 12. That's my favorite. Anyway, um, so basically, you just square the numbers from 1 to 15, for example, and you would have all of the perfect squares that you need to literally answer every single question, right? There is one important fact that we cannot ignore when we are talking about negative numbers and square roots in the same section. We have already seen that any number, positive or negative, when squared, the result will be positive, will be a positive number. After all, squaring a number is raising the number to an even exponent of 2. For that reason, no real number can be a square root of a negative number. So said a little differently, the square root of a negative number cannot be a real number. It's illegal for us to take the square root of a negative number. That's what it means, all right? So just to let you know, negative square root 9 is not the same thing as the square root of -9, right? Negative square root 9 means the opposite of the square root of 9, right? Which of course is 3, right? Or -3. But the square root of -9, right, is -9, which is not a real number. So there's no two numbers you can multiply together to give you multiply by itself to give you a -9. Right? No two real numbers will do that. So that's that. Now let's talk about those crazy questions that y'all seen for homework. All right. These are also like, I don't know if anybody here uses social media, but y'all ever see them post like a math question on social media, be like, what's the answer? And everybody got like 15 different answers.
Yeah.
All right, so that yeah. So this is that section right here. All right. So the order of operations. All right. So in previous chapters, we reviewed the basic arithmetic operations in the context of fractions and signed numbers. In a typical problem that we're going to encounter, however, there will be more than one operation to perform. For that reason, the order in which we perform the operations is important. Usually, if we do operations in different order, in a different order, excuse me, we will obtain different answers. So for example, consider the expression that we have right here, 8 divided by 4 divided by 2, right? If we perform the first division first, we obtain 2 divided by 2, which is 1. If we perform the second division first, right, we get 8 divided by 2, which is equal to 4. The answers are different, right? Which one is correct? The order of operations is largely a matter of convention that has been developed in history, and in fact, more of a question of topography than of mathematics, right? But you guys know how to do this, right? Left to right. Left to right. The same way we read a book, right? At least in this country, right? All right. So that being said, it is for the most part agreed upon as standard. We describe the order of operations as here. So here goes your order of operations. When an expression involves more than one operation, the operations are performed according to the following order. So the first thing you do is the operations inside of the grouping symbols, right? From inside to outside. So you do the inside parentheses first, then you do the outside parentheses afterwards, right? I'm sorry. Yeah. Parentheses are the most common grouping symbols, right? But there are many others, right? Such as like the square root, such as the fraction method. There's a whole bunch of them, right? Next, you want to do your exponents and your roots afterwards. So when more than one exponent or root occurs in the same expression, it is standard to evaluate them from left to right, right? After that, you do multiplication and division, right? When there are more than one multiplication or division in the same expression, they must be performed in order from left to right. Then finally, at last, you do addition and subtraction. When there are more than one addition or subtraction in the same expression, they must be performed in order from left to right. All right. And that's it. That's the order of operations. Go ahead.
Okay, 'cause I learned this before, in a
Gotcha.
different way, PEMDAS, for everybody. But,
Oh, for real? Oh, all right, let's talk about PEMDAS.
I just want to know, like, the multiplication and the division.
Yeah.
Sometimes, like you said, they got from left to right.
Mm-hmm.
Does that mean like if division is first, we don't multiply first? Or?
If division is first, you do division first, then multiplication. Yeah.
Yeah, that's what I was just saying.
All right.
I don't remember, but.
All right, let's talk about it.
Said right for the swap, then to do it like that was something.
All right, we gonna talk about PEMDAS right now. All right. Because there's a problem with PEMDAS. We're gonna talk about it. So hey dude. Yeah, that's you. All right, so check this out, check this out. So referring to the example at the beginning of the section, right? The expression 8 divided by 4 divided by 2 involves two division operations. Since both are at the same level in the order of operations, the division should be performed from left to right. So 8 divided by 4 is 2, and then 2 divided by 2 is 1, right? If we had wanted to write an expression where the second division was performed first, we would need to use grouping symbols, right? So if you had 8 divided by, in parentheses, 4 divided by 2, then you could do the 4 divided by 2 and then the 8 divided by 2 after that, right? So it is worth noting at this point that both the associative properties of addition and multiplication, as well as the distributive property of multiplication over addition, are all properties that concern the order of operations. So for example, the associative property of addition says that repeated addition actually does not need to be performed from left to right, but can be performed in any order at all. The same holds, of course, for multiplication. This is not true for subtraction or division, however. Neither subtraction or division is commutative or associative. All right, let's talk about PEMDAS. The unfortunate slogan of PEMDAS, right? Sometimes taught to help memorize the order of operations might imply that the first operation performed is parentheses. This shorthand terminology is misleading. First and foremost, because parentheses is not a representative of an operation. In particular, we draw special attention to the fact that often causes confusion, right? So parentheses is not the only grouping symbol, right? So I'm going to show you guys. Oh, we're gonna get to an example. Yeah. Y'all could put it on TikTok and be like, yo, what's the answer? All right, so parentheses, right, never mean multiplication. Parentheses are grouping symbols, indicating that what is inside the parentheses should be considered as a single expression, right? However, there's no operation symbol, right, is indicated between two expressions. The assumed operation would be multiplication. So if I have two parenthesis terms next to each other, right, you would assume like, all right, we're going to multiply them, right? But what we're talking about here is that whatever's inside the parentheses is what should be done first. It's a grouping system, right? You know. Go ahead.
But you would still divide it. You wouldn't multiply it, which is what I thought before you said, no, first you do it in the parentheses and then divide it by 8.
You would do in the parentheses first, and then you can do the multiplication.
So you do
Yeah.
multiply what's outside despite their.
You do what's inside the parentheses first, though.
Yes.
Then you multiply. Yeah. Gotcha. Yeah. I got you. Yeah. So just to clarify real quick, look, the expression 2 parentheses 3, right, involves multiplication 2 times 3 for the same reason that we will see that 2x involves multiplication 2 times x, right? In both cases, the multiplication is indicated by the fact that there is no symbol between the two factors of 2 and 3 in the first case, 2 and x in the second. Of course, 23 is simply the number 23. So the parentheses in the expression 2 parentheses 3 serves to separate the 3 as its own group, right, from the 2. Keep in mind that parentheses are not the only group in symbols. In addition to various shaped parentheses like brackets, braces, some commonly entered grouping symbols include the bar used to write a fraction, right? So when you have the fraction bar, you have the numerator by itself that's grouped by itself, and you have this denominator by itself that's grouped by itself, all right? Where the numerator and denominator are both considered as two separate groups, and the bar over an expression in a radical symbol, square root, right? Where everything inside the radical sign under the bar is considered as one group. All right, so let's look at an example. This is gonna be fun. Yeah. I feel tired. I'm just gonna copy this. So here's an example right here. So y'all could tell me what to do. I got 3 minus 2 parentheses and 4 plus 11. Okay, what should I do? What's negative 4 plus 11? 7. Okay, so I got then what? 3 minus 2 times 7, right? And what should I do after that? Okay.
Yeah.
And what's that?
Negative 2 times 7.
Mhm. Which is what? All right, so now I got 3 minus 14, which is what? Negative 11. There we go. All right. So that's it. Not bad, right? That's the hardest homework y'all got tonight. That's the hardest homework y'all got tonight. The rest of it is easy. Promise you, this is not bad. It's not bad. You can distribute it. Yeah. It would. Yeah, it would. Yeah. All right, this one's even easier. Because now that we got the hard one out of the way, let's look at the easy question. All right. So how we do this? So I got -2 minus -6 over 1 minus 5. So help me out. So this is the easy question. The first one was the hard one.
Divided by 1.
So what's the answer? You tell me. I know y'all know how to do this. Yeah.
Okay, that's the.
Yeah. So tell me what that means. When I have it in parentheses, what does that mean? Yeah. So remember how we did this before, right? We have the -2, and then the minus means that I want the opposite, right, of the -6. So it's going to be +6 over 1 minus 5. All right, so what's -2 plus 6? 4. Good. And then what's 1 minus 5? No. -4. Now we're talking. All right, so what's 4 divided by -4? -1. Now we're talking. All right. So we good. Not bad, right?
I did pay attention for this one. So.
What you want to do the top, the numerator by itself, do the denominator by itself. Then when you get it down to like a number divided by number, divide it. That's it. Because you have $1 and you have a bill for $5.
It's 1 minus 5.
Yeah.
Sorry.
Yeah.
I'm just gonna cross this out.
Just do the numerator by itself, then do the denominator by itself. Yeah.
Already from step by step.
Got you.
Every time you move it, you have to change the operation.
Yeah.
Goes from the opposite.
Mm-hmm.
So it was multiplication with division. Okay.
What do you mean?
That was -2 times -1.
That's if I'm dividing a fraction by a fraction. Yeah, that's different. Not really.
So now you don't really know what it feels. Sometimes it gets jumping up. You'll different way. Yeah.
Just type it in the calculator.
Oh.
All right. So this is the easiest one. All right. Yeah. So tell me what to do first.
You write it down for.
Which one? I got a whole bunch of it. Which one? Which one?
The -5. No.
All right. Why are you doing that one first?
Exponent.
Good. So tell me what to write. So what's -5 squared?
Wait, hold on. I got you right now.
10, no.
No, it is. That's not 5.
25, good. Positive 25, because a -5 times -5, right? Okay. All right, help me out with the second part.
-4 times 1.
Okay, I'm with that. So that's gonna give me 25. And what's -4 times 1 again? Y'all close. -4. All right. What's next? Which is what?
Writing it down.
Good. So this is 25 plus 24, right? Because we just multiply them together, right? -4 times -6, positive 24, right?
Wait.
48? Close.
49.
49. Okay. Now what's the square root of 49? I'm impressed, I'm not gonna lie. You don't? Use PEMDAS. That's all this is. It's just PEMDAS.
So PEMDAS is parentheses.
Exponents. Yeah. Then multiplication, division, then addition, subtraction.
Okay, got it.
From left to right, the same way you read a book. What they say? What's that mnemonic again? Like, please excuse my dear Aunt Sally, something like that. Yeah.
We like food.
That's cool. I'm telling you, just put them on TikTok. Be like, oh, ain't nobody gonna get this. Like,
Yeah, this one was like. That's it.
but literally, like, this is the max that your homework is. Like, it's not gonna get more complicated than that.
That is not
Yeah.
what it is.
It's not. It's, yeah, like that's it.
This homework or in general?
This homework, yeah.
Yeah.
This homework is gonna be the hardest homework for the whole semester. Yeah.
How you know?
Not for real, for real. Statistics is really easy. Like it's not hard, you know. So we close with the reminder that the commutative and associative properties give great flexibility with the order of operations involving addition and multiplication. So for example, consider the expression 22 minus 75 plus negative 18 minus 52 minus negative 16 plus 48 plus negative 12. According to the operations, the six operations would be performed from left to right. However, changing all subtractions to addition of the opposite and using the commutative property to change the order and the associative property to regroup the positive and negative numbers together, it is much easier to perform. Let's say 22 plus 16 plus 48, in parentheses, plus bracket negative 75 plus negative 18 plus negative 52 plus negative 12, right? Long story short, they're just trying to show you that you could play with the associative properties and switch things around to get the same answer, right? If you're confused, just do what you know how to do from left to right, PEMDAS. What happened?
Hey, what else?
You can switch the numbers around and get the same answer. Yeah, that's all that means. Yeah. And then you get the same answer. Yup.
You wanna do one later?
Hmm?
What do you wanna do?
That's simple. That's just adding. Y'all know how to add. Y'all better adders than I am. Hmm. All right, let's see if this works. I'm gonna pivot now. It's gonna be a hard pivot. Did it work? What the hell? All right, whatever. No. Oh, just an example. So let's talk about statistics. All right. What is it? So I'm gonna give y'all the basic definition of statistics right now. So statistics is a study of how to collect, organize, analyze, and interpret numerical information from data, right? So they're gonna give you a whole bunch of numbers in the form of data, and you're gonna organize it, analyze it, interpret it, and then you're gonna make a decision, right? Statistics helps you to make decisions, right? This is why everybody's major has to take it.
Oh, how do we have you?
Yeah.
Oh.
Take your time. Statistics is both the science and of uncertainty and the technology of extracting information from data. That's a fact. All right. You didn't see it in Brightspace? Got you. Got you.
Evil.
Yeah, it's there. So like the blue words, those are links. So like when you click it, they open up into like another page. So the general prerequisite for statistical decision making is the gathering of data. So first we need to identify the individuals or objects to be included in the study and the characteristics or features of the individuals that are of interest. All right. So basically, before we can get into doing some like good statistics, we gotta build vocabulary a little bit. So that's what we're doing today. Just building our vocabulary up. Mhm. Yeah. And literally, that's what your homework is, just vocabulary questions. Yeah. So you finished the statistics homework already and you still working on the other one? Got you. You on question number 3? And there was only 3 questions? That's impressive. That's the wrong one. So let's define individuals and variables. So individuals are the people or objects included in the study, and the variable is a characteristic of the individual or of the let me say that again. A variable is a characteristic of the individual to be measured or observed, right? So let's come up with like a fake study. I don't know. Mm, all right, let's say that we're gonna run like an experiment or something, right? Let's say we want to figure out how many people, like in New York City, tried a chopped cheese sandwich. I'm just making it up, right? So the people who tried the chopped cheese, right? Those are the individuals that we're studying, right? Characteristics behind them might be like, let's say, the height of the individuals that tried it, or let's say, yeah, like different characteristics of people, the hair color of the people that tried it, the eye color of the people that tried it, you know, the level of education of the people that tried it. Right. You know, so all of those characteristics, those are the variables, right, of the individuals who try the chopped cheese, you know? Yeah, exactly what this is. Huh? The neighborhood, that's another way to do it too. That's getting advanced. That's like next week's topic. Yes. Mm-hmm. Yep. So something else to say about the variables, right? You have 2 different types of variables, right? Like characteristics of the people that you're observing, right? You have something called qualitative variables, and you have something called quantitative variables, right? So let's define that real quick because those are some big words. Mhm. This that Scrabble 40-point word right here. They got a Q and a U, you know? All right. So a quantitative variable, right, has a value or numerical measurement for which operations such as addition or averaging make sense. But a qualitative variable describes an individual by placing the individual into a category or group, such as like male or female, right? So going back to our chopped cheese, right? So like if we're talking about a person's height, for example, right? That would be quantitative, right? Because that's a number, 5'6", 6'2", 8'3", whatever, right? Or like weight and stuff like that, right? Now, a qualitative variable, right, would be like say eye color, brown eye, blue eye, right? It's not a number. It's like a word to describe it, you know? Yeah. Or what's another characteristic we say hair color, that could be like another one. So quantitative, number, qualitative, it's like a description. All right. Okay. Mhm. Go ahead.
That was the last person that started saying to me, he gave her all the numbers and names. No way. Like the 58 names, I just the cool.
For real?
He was like.
Like the whole phone book and was like he's like, yo, find this pizza spot. Like
Yeah, but it certainly must be less range, you can be able to compare something, which is which.
right. Another issue that we have when we're doing a study like this, right? How can I describe this now? What kind of data do I have? Right? So what I'm trying to hint at, right, is do I have like let's say that going back to the chopped cheese, right? I want to know how many people in New York City try the chopped cheese, right? I ain't got time to go out there and find everybody and be like, yeah, what you think? What you think? So like let's say that I'm just working with the people in this classroom, right? So that's a different kind of data sample from the whole thing, right? So that's what I'm trying to hint at.
Category.
Not categoric. I'm trying to describe the difference between like a population data set and a sample, right? So population is like it's like everybody, right? So that would be everybody in New York City. But everybody in this classroom would be a sample, right, of the people that are in New York City, all right? But just to formally tell y'all what it is. So in population data, right, the data are from every individual of interest. In sample data, the data are from only some of the individuals of interest, right? Oh, thank you. Yeah, yeah, go ahead. No problem.
I'm just gonna write population
Yeah.
data would be the entire like state of New York. Sample data would be our class.
Right. Hmm. Yep, yep. Whatever helps you do your homework, I'm cool. Another thing to say about data, right? So if you have data from a population, right, that means that you have the complete set of data. You have everything, right? But if you have data from a sample, right, that means that that data is incomplete, right? So like everybody in this room might have like together everybody in the room might have a particular opinion about the chopped cheese, right? But the room next door might have their own opinion about the chopped cheese, and the room next to that might have their own opinion, right? Like because we're samples from the entire whole, all right? A lot of definitions today. Yeah. Yeah.
That's what you think, man.
Thank you. Thank you. I enjoy this.
You would have had like monotone voice again, or like a different accent.
Oh, you don't like my accent? Yeah, yeah. You think so?
Like, read his lips.
How how that happen in English class? That don't make sense.
Right.
Nah, I'm not gonna lie though. Yeah. Nah, I've actually like heard like on Rate My Professor like complaints about that. Yeah. Yeah. All right, let's go a little bit deeper. So a population parameter is a numerical measure that describes an aspect of a population, right? A sample statistic is a numerical measure that describes an aspect of a sample. All right. Big vocabulary words now, right? We got parameter and then we got statistic. Mhm. What? Right. All right. So let's say let's say that I'm gonna change the example up. Hold up. Mm,
I was thinking that.
kind of. Kind of. So I'm trying to come up with a nice example for y'all. So let's say that on average, everybody in New York City prefers American cheese on their chopped cheese, right? Right? Yeah. I don't know. I'm just right. But but let's say that everybody in here agrees that like nah, you can't have the chopped cheese without unless it's Gouda cheese that's on it, right? So that's an example, right, of a sample statistic, right? So everybody in here, right, on average, we want Gouda cheese on our chopped cheese, right? But the state, or well, not the state, the city, right? They agree that nah, it should be American cheese. I don't know. Gouda is a cheese though. I don't know. I'm just like throwing out an example, right? Long story short, when you have your data, right? Say you have the population data and you find, let's say, like the average of that data, right? What you found was a parameter for the data. So, like, in a sense, you found, yeah.
Yes, I remember they did that.
You tell me what's average. It involves something like that.
I know
Yeah.
it was like. Um.
Wait. Don't tell her that. How you get the average in your class?
That's like what the middle of the population.
Okay.
That makes sense.
Okay.
The average is the middle. Like, how is it?
So like let's say in your bio class, right? You got a average of 87 after you took 3 tests. How did you get the 87?
Subtracted. You gotta add everything. And then, yeah, and then.
You add and then you do what?
Divide.
By what?
By the number. Divide by the number.
Right. Right. Mm-hmm.
So average is divided.
Adding and then dividing. But what it's telling you is it's telling you the middle of the data, right? Huh? Yeah. She knows what it is. She just like she might not have thought of it before, you know. Oh, we getting up to that. Yeah. That's building the vocabulary right there. That's building the vocabulary right there. All right, let's look at an example real quick.
Yeah.
Real quick. All right, so the Hawaii Department of Tropical Agriculture is conducting a study of ready-to-harvest pineapples in an experimental field. The pineapples are the objects, the individuals of the study. If the researchers are interested in the individuals' weights of the pineapples in the field, then the variable consists of the weights, right? So at this point, it's important to specify units of measurement and degrees of accuracy of measurement. So the weights could be measured to the nearest ounce or gram. Weight is a quantitative variable because it is a numerical measure, right? If weights of all the ready to harvest pineapples in the field are included in the data, then we have a population, right? So the average weight of all ready to harvest pineapples in the field is a parameter, right? Because it's describing the population, right?
Yeah.
Suppose the researchers also want data on taste. So now a panel of tasters rate the pineapples according to a category of poor, acceptable, or good. Only some, right, that's a sample. So only some of the pineapples are included in the taste test. In this case, the variable is taste, right? Yeah. Now this is going to be a qualitative or a categorical variable because only some of the pineapples in the field are included in the study. So we have a sample there, right? So the portion, yeah. So the portion of pineapples in the sample with a taste rating of good, that's going to be a statistic because it's describing the sample, right? That's what that is. You're welcome. They're not bad though.
They're not bad, but
Yeah,
it's just very.
got you. We got a little bit more to talk about next time. Well, look forward to seeing y'all then. Yes, I do.
So